section 6.4, we're going to take what we learned about a parallelogram and we're going to go further because we're going to talk about rectangles, and rectangles are specific types of parallelograms. They're more specific, all right? So this is a parallelogram with 4 right angles is called a rectangle. That should seem familiar to you because you've used them since you were little. Keep in mind a rectangle is a parallelogram, so the magic 7 that we talked about in the last set of notes also applies to a rectangle already. So it already has 7 before we started. So that's what I said here. Since a rectangle is a special type of parallelogram, it has all the parallelogram properties that we studied. This says last class, but it would be last notes. So it's going to have the magic number 7 because there are 7 things that are true about it. Now, there are a couple of other things that are true about a rectangle. In addition to being the parallelogram, it's got some other properties. So we're going to make a rectangle using the grid lines. So all I'm going to do is I'm just going to darken in a grid line to make sure that I have 4 right angles. And it can be as big or small as you want. But go ahead and make yourself a rectangle. Most kids know how to make rectangles before they even start geometry. Let's go ahead and mark opposite sides parallel to show that it is a parallelogram. And then what we're going to do is we're going to come up with 2 extra features in a rectangle that a regular parallelogram, I shouldn't say regular, a normal parallelogram doesn't have. Okay, so it says to draw in both diagonals. So let's take our straight edge, or you can just sketch them in. Sketch in your diagonals. Now we know that they bisect each other, and we know that they bisect each other because they did in a parallelogram, and a rectangle is a parallelogram. But there's something else about a rectangle's diagonals that's pretty cool. So if I look, then I can measure. So I'm going to do this in centimeters. So measure your diagonals. And they'll all be different sizes, but I got 5.5 for this diagonal. And now I'm going to measure this diagonal. And I got 5.5 centimeters. So what I found out is, in a rectangle, that's not true in every parallelogram, but in a rectangle, not only do the diagonals bisect each other, the diagonals are congruent. All right, so it says, using this property and the fact that the diagonals will also bisect each other, since every rectangle is a parallelogram, the diagonals will form 4 types of triangles. So let's go to the top, and let me show you what I mean by this. These diagonal pieces match each other, but they also match these 2 because the diagonals bisect each other and are congruent. So what kind of triangles do I have? Well, this is a triangle with 2 congruent sides. It's isosceles. This is a triangle with 2 congruent sides. That is isosceles. These triangles will match each other. They will be congruent to each other because of SAS. So SAS is a shortcut, so picture those blue ones as matching. And then over here, you have a different set of isosceles triangles. So the pink isosceles triangles will match each other by SAS as well. So you have 2 sets of congruent isosceles triangles. So that's what we're going to fill in here. The diagonals will form 4 congruent isosceles, well, I shouldn't say it like that. Let's just say 4 isosceles triangles. 2 sets are congruent. They're not all 4 congruent to each other. Okay, now how can you use that to help you? Well, you guys are going to try these problems in just a second when we're done, but I want to go up and show you an example. So let's say that this angle right here is 40 degrees, okay? It's hard to see. I shouldn't have colored all that in. If that angle is 40 degrees, this is an isosceles triangle, so this base angle will also be 40 degrees because the base angles in an isosceles triangle match. Okay, that means since the blue triangles are congruent, this angle is 40 degrees and this base angle is also 40. So do you see how all 4 of those blue base angles match? Now, what would the pink base angles have to be? Well, in a corner of a rectangle, that has to add to 90. So this base angle would be 50, and that makes this one have to be 50. Those have to match. And then because the triangles are congruent, these will also be 50. So keep in mind that you can use that idea to help you in a lot of these problems. All right? Okay, so another thing I want to show you, we're going to go skip these. You're going to do them in a second. Go down to the bottom. There's an example if you want to look on it in 424, but I already drew the picture in for the question they wanted you to try. So here is a rectangle, and if you look, this blue diagonal is 5y plus 1, and the yellow piece of the diagonal is 3y minus 5, and they would like you to solve for y. So what you have to think about is all four little pieces in a rectangle match each other. That only happens in a rectangle so far. And so what I'm going to do is I'm going to need to double that little yellow one to equal the big one. So here's what that would look like. 3y minus 5 plus another 3y minus 5. That makes the whole diagonal. And then that diagonal will match the blue one because the diagonals are congruent. So that will match the big one, which is 5y plus 1. Some of you might want to write this as 3y minus 5 equals 5y plus 1. And you can do that if you'd rather, and then distribute and solve from there. Now, when you guys get this solved, I don't know if I can find what I got on this. I probably can. I got y equals 11, but that's just algebra, so I won't bore you with all the details of algebra. But that's how you would set it up to set the little piece equal to the big. You just double the little one. Okay? All right, so we have one more example, and we're going to do this example, and it's going to be kind of like what we practiced with slopes on the other page. So it says you can also use the properties of a rectangle to show that a quadrilateral is a rectangle. So here's what I'd like you to do. Like we were doing on the last set of notes, go ahead and sketch a picture of what may look like a rectangle. We don't know if it is, but we're going to put this in. So the name of it is JKLM. So we're going to go in a circle. JKLM. And it has to be in a circular order. When you go to name it, you can't go diagonally. Okay, we are going to be doing the slope formula again. So I'm going to write the slope formula out. We practiced the slope formula before. So what I'm going to do is I'm going to write in all four slopes, and then we're going to decide what we think this is. Okay? So in your picture, write in the slope of JK is 1/3, and the slope of ML is 1/3. So right away, what do we notice about the top and the bottom? They are parallel because they have the same slopes. Now I'm going to write in the slope of JM. It is -3, and KL is -3. Now, you could put -3/1 if you wanted to. Right away, I notice that those slopes match each other, so these sides are parallel. So based on what we talked about in the last section, this is a parallelogram. And the reason it's a parallelogram is opposite sides are parallel. But is it something more? Well, let's look at the corners. What do you notice about the corners of these two slopes? They are reciprocals, and they're opposite reciprocals. So you have to think way back. Opposite reciprocals means that you have perpendicular lines. That means there's a right angle in that corner of your parallelogram. Okay, let's look at another corner. Is that a set of opposite reciprocal slopes? Yes, there's another right angle right here. What about here? Yes. And what about here? Yes. That means we have a parallelogram with four right angles. So instead of calling this a parallelogram, we have a better name for it. We can actually call it a rectangle. And that's because it's a parallelogram with four right angles. So that's the best name for it, rather than just calling it a parallelogram. So what I did is I used my slopes to prove that it was a parallelogram, and then I used my slopes to compare the corners to make sure they were opposite reciprocals. If they are, the corners are all right angles because they would be perpendicular to each other. Okay, so you're going to go back and try these two that we skipped and then check them.